Imagine this. You walk into a small office, there is only one worker inside. He reads instructions, he makes decisions, he does calculations, and he controls everything in this office. This office is a computer, and that worker is the CPU. Today, we're stepping inside this office to understand how the CPU really works. Welcome to IGCSE Computer Science 047 in Chapter 3 Hardware. The CPU stands for Central Processing Unit. It is the brain of the computer. The CPU processes data, executes instructions, controls all operations. In the exam, you can write the CPU processes data and instructions and controls the operations of the computer. Inside the CPU, we have the control unit. Think of it as the part that reads instruction and tells everything what to do. It fetches instructions, decodes instructions, sends control signals. In the exams, write the control unit decides whether instructions and controls the execution of instructions. Next, we have the ALU, Arithmetic Logic Unit. This part performs calculations. It adds numbers, subtracts, compares values, makes logical decisions. In the exam, write the ALU performs arithmetic and logical operations. Registers are very small, very fast memory locations inside the CPU. They temporarily store data and instructions. Think of them as small papers on a desk, always ready to use. In exams, write registers are small, fast storage locations inside the CPU. Now imagine this office has only one file cabinet. Inside this cabinet, instructions and data. Both are stored together. This is called the von Neumann architecture. In exams, write this exactly. Data and instructions are stored in the same memory and share the same bus. This is very important. But there is a problem. Only one file can be taken from the cabinet at a time. This causes delay. This delay is called von Neumann bottleneck. To move information, the CPU uses buses. Think of buses as paths connecting the desk and the cabinet. There are three main buses: address bus, data bus, and control bus. In the exam slide, buses are used to transfer data, addresses, and control signals. Now let's look at the important registers. PC stands for program counter. It stores the address of the next instruction. MAR, memory address register. It stores the address being accessed. MDR, memory data register, stores the data or instruction being transferred. ACC, accumulator, it stores the result of the calculations. Here's the exam tip. Always write register names in capital letters. Next, system clocks. The system clock controls time. Each tick tells the CPU to perform one step. The faster clock speed, the more instructions per second. In the exam, write system clock synchronizes operations in the CPU. Next, we have fetch, decode, execute cycle. Now let's put everything together. CPU follows the same routine again and again. This is called the fetch, decode, execute cycle. First, fetch, PC means program counter, gives the address of the next instruction. That address goes into the MAR. The instruction is fetched from memory and stored in MDR. Next, decode. Control unit decodes the instruction and understands what needs to be done. Finally, execute. The ALU performs the operation. The result is stored inside the ACC. Then the PC moves to the next instruction and the cycle repeats. In exam, write the fetch, decode, execute cycle continues until the program ends. Today, what we have learned: CPU and its components, von Neumann architecture, CPU buses, CPU registers, system clock, fetch, decode, execute cycle. This topic gives guaranteed marks if you understand clearly. If this video helped you, like and subscribe for more IGCSE Computer Science lessons. See you in the next video.